In this video, I'm going to show you how you can calculate the half-life from your experiment. So let's say at the start of the experiment at 0 hour, you started your experiment, and then 2 hours in, the mass of your object is now 8 kilograms. And then 5 hours later, from 5 hours later, that would take you to 7 hours. The mass of your object is now at 1 kilogram. So calculate the half-life. So here the half-life is when it's 4 kilograms, but here you've got a weird mass at 1 kilogram 5 hours later. So your job is to calculate the half-life. Okay, so first step is to come up with the equation for this line here. We know it's of the form a e to the power of minus kt. So our job is to find a and k such that it passes through here and it passes through here. Okay, so hang on. So we would put 2 into the t, and then at 2 hours the mass is 8 kilograms. So that will then give us this. And then put the 7 into the t, and then that will then give us a mass of 1 kilogram. So basically we want to find a and k such that both of these are satisfied simultaneously. Okay, so hang on. So divide equation 1 by equation 2. So this divided by this will give you 8, and then this divided by this, the two a's will cancel each other out to give you this. And remember, x to the power of a divided by x to the power of b. Whenever the two bases are the same, you can just simply get a take away b. So you can just simply get this take away this. That will give you a positive 5k. And then take the natural log of both sides. That will then give you this, and then divide by 5. So k equals this. Now we've got k. So put the k back into one of the two. So let's just arbitrarily choose this one here. So we're going to put k back into here. So this whole thing here will then become this. So now it's just a matter of finding out capital A. So hang on, let me think. So from here, there are more efficient ways of doing this, but let me just take it step by step. So I'm going to push this back up here. So that will give me to the power of minus 2 over 5. And then now the e is right next to the natural log. So push this thing here up to here. That will then give us 8 to the power of this thing here. Now that the e and the ln are right next to each other, they in a way cancel each other out to give us this. So to get a on its own, divide both sides by this thing here. So that will then give us this thing. So remember, whenever the two bases are the same, so you can imagine this is to the power of 1. So it's really this take away this. So take away a minus would be a positive. Well, it will then give us this. A equals this. So now we've got our equation. So this is our A here, and this is our K. Hang on. This is our K here. Okay, so punch this into decimals. It will then give you this, and then our line. You will notice that our line will pass through these 2 points from our experiment. So to find the half-life, let's put 0 into the t. Put 0 into the t. So to find the half-life, you have to do this. Put the 0 into the t. So this whole thing here will be 0. So e to the power of 0 will be 1. So when time equals 0, the mass will be 8 to the power of 7 over 5. So we know the initial mass of the object at time equals 0. If you want to know the half-life, well, your half-life will be, you want to find a time. You want to find a time when the mass is now half of its original. So so get your whole mass divided by 2. You want to find a time when the mass is half of its original mass. So so half of it will be this, and then well, put this into here, and now you're trying to find a time when it would be half of its original mass. So this whole thing here will then become this, and now you're looking for a time when it will be half of its original mass. So you're looking for this time here. Okay, so now divide both sides by 8 to the power 7 over 5. That will then give you this thing here. And again, there are more efficient ways of doing this, so let me just take it step by step. Let's push this back up here. That will then give us this 8 to the power of this thing here. And then now the E is right next to the ln. They in a way cancel each other out to give you this. Okay. By the way, when you're here, you can just take the natural log of both sides. So so natural log of a half, and then these two, they cancel each other out, and so on. Or you blah 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 to take you to here, and then you can take the natural log of both sides. When you take the natural log, this is able to come down to give you this. Well, I'm assuming you can jump from here to here. Do whichever way you want. That will then take us to here. Okay, and then you can imagine this as being 2 to the power of -1. 2 to the power of -1 is 1 over 2. And then that, well, from here that will then take you to here, and then you would divide both sides by 8, natural log of 8. So that will then give you this thing here. I hope you can follow what I'm doing. I've explained it badly, but from here that will then take you to here, and then times both sides by 5. That will then give you this. So this is a half-life. You see, this is a time. This is a time when the mass will be half of its original. Half of its original. Okay, so that's your half-life. Yeah, that's your half-life. So what that means is, hang on, let me elaborate on this. So this is your half-life. This is your half-life. So what that means is this, hang on. What that means is 2 hours into the experiment, your mass was 8. Half of that would be 4 kilograms. You see, if you get 2 hours plus your half-life, the amount that we just worked out, it will take you to right here. It will take you to right here. I hope you can follow. I've explained it badly, but 2 hours plus your half-life will take you to right here. Okay, so the half-life is this thing here.